Good morning, students. Today we will study some more concepts of lesson solution. First of all, we will study about solutions of solid in solid. In such a solution, both the component, any solute and solvent, are in solid state. It means a homogeneous mixture containing two solid components, solute as well as solvent, is called a solid in solid solution. Such solution can be of two different types. Solid in solid solutions are solid in solid solution are of two different types. One is the substitutional solid solution and second is the interstitial solid solution. यानी a solid in solid solution or a solution containing two solid component can be of two different types. One is the substitutional solid solution and second is the interstitial solid solution. First, what is a substitutional solid solution? Substitutional solid solution. Such a solid solution is formed when atoms of one element, यानी solid element, present at lattice sites are replaced by same sized atoms of other element or other solid. Meaning substitutional solid solution, atoms of one element which are present at its lattice sites are replaced by some same sized atoms of other element. For example, we can take the example of brass, bronze, monon metal, alloy gold. These all are the alloys and they are the substitutional solid solution. For example, in brass, some of the copper atoms are replaced by zinc atom. Yani some of the copper atoms which are present at their lattice points or lattice sites are replaced by zinc atoms. One more thing, substitutional solid solution is formed when the atomic radii or atomic size of both elements is almost same, and when element A and B, which are the component of a substitutional solid solution, have same or almost same atomic radii. यानी atomic radius of A and atomic radius of B if are equal or almost equal, we can obtain a substitutional solid solution. A substitutional solid solution can be represented like this. Suppose these are the atoms of A element in its pure state. They are closely packed and present at their lattice points or their lattice sites. Now, if some of the A atom are replaced by atoms of some other element like B, so this solid solution in which some of the A atom are replaced by atoms of some other element B can be called is substitutional solid solution. For example, alloy gold is obtained by mixing some copper or silver in gold, and some of the gold atom are replaced by either copper atom or silver atom. First is the substitutional solid solution. Now, second is interstitial solid solution. In such a solid solution, atoms of one element यानी host element are present at their lattice points, and the atoms of and the small sized atoms of other element are occupied in interstitial sites or voids present between the atoms of host element. For example, tungsten carbide. In tungsten carbide, tungsten atom which are larger in size, they are occupied in regular manner, but carbon atom which are very small in size are occupied in interstitial sites of tungsten. Mean tungsten carbide can be represented like this. These are the large sized tungsten atoms which are present at the lattice points. They all are the tungsten atoms. And these are the interstitial sites which are left between the tungsten atom. And in these sites, small sized carbon atoms are occupied. Mean these large sized atoms are of tungsten and these small sized carbon atom are occupied in interstitial sites. Such a solid solution is called substitutional interstitial solid solution. Such a solid solution is called interstitial solid solution. One more example of such solid solution is steel, that can be considered as iron carbide. In steel, or you can say iron carbide, iron atoms are very regularly arranged. They are present at their normal lattice points, but carbon atom will be occupied in interstitial sites left between the iron atoms. So these are the two examples of substitutional solid solution. Now, next topic we should study, that is the solution of solid in liquid. Solutions of solid in liquid. In such a solution, solute, that is solid in state, is dissolved in liquid solvent. For example, some salt or sugar is dissolved in water, or some iodine is dissolved in benzene or carbon tetrachloride. Now, first of all, solubility of a solid in liquid. So, solubility of a solid in liquid can be a solid in liquid at a given temperature can be defined as the amount, or you can say the maximum amount of solid, that is solute, which can be dissolved in 100 gram of liquid, यानी solvent, at a given temperature to form a saturated solution is called solubility of solid in liquid. The maximum amount of solid, that you can also write in grams, which can be dissolved in 100 gram of liquid, solvent at a given temperature to form a saturated solution is called solubility of solid in a liquid. For example, solubility of sugar in water is almost 35 gram per 100 gram of water at 25 degrees Celsius, which means that 35 gram sugar can be dissolved in 100 gram of liquid water at 25 degrees Celsius, and a saturated solution of sugar in water is formed. Yani this is the maximum amount of sugar which can be dissolved in 100 gram of water at 25 degrees Celsius. After dissolving 35 gram sugar in 100 gram water at 25 degrees Celsius, we obtain a saturated solution of sugar in water. So again you see what the meaning of solubility. So solubility of a solid in liquid is the maximum amount of solid in grams which can be dissolved in 100 gram of liquid at a given temperature to form a saturated solution. Now, next is factors affecting solubility of solid in liquid. Here we will discuss some factors which affects the solubility of a solid in a liquid. First of all is the nature of solid, that is solute, and nature of solvent, that is liquid. I think we have already studied earlier a general rule that like dissolves like. And according to this concept, a solid which is similar in chemical nature with the liquid solvent dissolve that. For example, ionic or polar solids dissolves more in polar solvent like water, and they dissolve to very less amount or in negligible amount in non-polar solvent like benzene, toluene, carbon tetrachloride. For example, sodium chloride, that is an ionic compound, dissolves in water to larger extent. But sodium chloride is almost insoluble in a non-polar solvent like benzene, toluene or carbon tetrachloride. Likewise, non-polar solids, yani solids whose molecules are non-polar, are almost insoluble in water or very less soluble in water, but they are more soluble in non-polar organic solvents like benzene, toluene, carbon tetrachloride or carbon disulfide. For example, naphthalene, anthracene, dissolve in benzene or in toluene to large extent, but they are almost insoluble in polar solvent like water. It means solubility of a solid in a liquid solvent is decided by nature of solid itself as well as the nature of solvent in which solid is dissolved. And for solubility, there is a general rule that like dissolves like, which means that the polar or ionic compounds are more soluble in polar solvent like water, but non-polar solid whose molecules are non-polar, they are more soluble in non-polar solvents like benzene or toluene, but they are very less soluble or insoluble in a polar solvent like water. One more example, iodine. We know iodine is a non-polar solid. Iodine molecules are non-polar, and iodine is very less soluble in water, but it is highly soluble in non-polar solvent like carbon tetrachloride or chloroform. So solubility of a solid in liquid depends upon nature of solid as well as the nature of solvent. one more thing which we are studying in class 1, solubility of this ionic solid. Solubility of an ionic solid in water is decided by two type of enthalpies, that is lattice dissociation enthalpy that is denoted by delta H lattice, and hydration enthalpy that is also called heat of hydration represented as. We know when ionic solute dissolved in water, when ionic solid is dissolved in water, its component ions are separated from each other. And to separate these ions of an ionic solid from each other, or to dissociate this ionic crystal into its component ion, some heat is absorbed, some energy is consumed, that is called lattice enthalpy. But in aqueous solution, these ions are surrounded by layer of water molecule, and this surrounding of ions by water molecule is called hydration of ion. And during hydration of ion, some energy is evolved, some heat is released, that is called hydration enthalpy. And we know only those ionic solid dissolved in water whose enthalpy of hydration is either more than or almost equal to lattice enthalpy. If lattice enthalpy of ionic solid is much more than its hydration enthalpy, your ionic solid does not dissolve in water. यानी ionic solid will dissolve in water when enthalpy of hydration of ionic solid is either more than lattice enthalpy or equal to lattice enthalpy, almost equal to. But if lattice enthalpy of ionic solid is much more than hydration enthalpy, your ionic solid will not dissolve in water. For example, sodium chloride is water soluble because lattice enthalpy of sodium chloride is almost equal to its hydration enthalpy, or lattice enthalpy is little more than hydration enthalpy. But barium sulfate, that is also ionic compound, it is almost insoluble in water because lattice enthalpy of barium sulfate is much more than hydration enthalpy of the solid. It means solubility of ionic solid in water is decided by two type of enthalpies, and these enthalpies are lattice enthalpy and the hydration enthalpy. For ionic compound, lattice enthalpy if equal or greater than lattice enthalpy, then hydration enthalpy of ionic compound is either equal or greater than lattice enthalpy, your ionic compound may dissolve or will dissolve in water. Now second is the second factor is temperature. Temperature is also a very important factor which decides the solubility of solid in a liquid. When a solid is dissolved in liquid and a saturated solution is formed, this equilibrium is established. Yani solid, that is the solute, liquid, that is the solvent, and when this solute dissolve in solvent to form saturated solution, this physical equilibrium, that is called solid solution equilibrium, is obtained. And this process, this equilibrium, can be either endothermic or exothermic. And when solid dissolves in liquid, either some heat will be overall absorbed or some heat will be overall evolved. If overall some heat is absorbed, this process will be endothermic and delta H will be positive. And if solid when dissolved in liquid, overall some heat may be evolved, this equilibrium may be exothermic and delta H may be negative. Now, depending upon effect of temperature on solubility of a solid in liquid, solids can be of three different types. First, solids whose solubility in liquid increases with increasing temperature. And first of all, we will study those solids whose solubility in liquid increases with increasing temperature. There are some solids like potassium nitrate, sodium nitrate, ammonium chloride, sodium and potassium chloride. These are the solids whose solubility in water increases with increasing temperature. Yani potassium nitrate dissolves in water to less extent at low temperature and it dissolves to larger extent in hot water. Or solubility of potassium nitrate in water will increase with increase in temperature. The reason is when these solid, yani these one solid, when dissolved in water, the dissolution is endothermic. Mean when these solids dissolve in water, the process is endothermic. The dissolution in water is endothermic. And we know according to Le-Chatelier principle, endothermic equilibria are favored by high temperature. This equilibrium will shift in forward direction with increase in temperature, and solubility of solid in liquid or solubility of these solid in water will increase with increase in temperature. Again I am repeating, when these solids are dissolved in water, the solubility in water increases with increase in temperature, because when these solids dissolve in water, the dissolution in water is endothermic, and this equilibrium shift in forward direction according to Le-Chatelier principle on increasing the temperature. Now the second is solids whose solubility in liquid, or you can say water, decreases with rising temperature. Decreases with rising temperature. And second type of solid are those whose solubility in water or solubility in liquid decreases with rising temperature. For example, seric sulfate. Likewise, lithium carbonate, sodium carbonate, monohydrate. These are those solids whose solubility in water decreases with rising temperature. The reason is when these solids are dissolved in water, their dissolution in water is exothermic. Means when these solids are dissolved in water, some heat is evolved, and this equilibrium, this process is exothermic. And we know exothermic equilibria are favored by low temperature. Mean this equilibrium, solubility equilibrium, will shift in backward direction with rising temperature, and solubility of these solid in water decreases with rising temperature. So I have told two types of solids. First, the solid whose solubility in water or solubility in liquid increases with increase in temperature, and second are the solids whose solubility in liquid or solubility in water decreases with rising temperature. But there is third category of solids also. That is the solids whose solubility in water does not regularly increase or decrease with increase in water. With increase in temperature. For example, sodium sulfate dihydrate. It is a crystalline salt containing water crystallization, and it is sodium sulfate dihydrate. Solubility of sodium sulfate dihydrate in water increases with increase in temperature up to 32.4 degrees Celsius. But when the temperature is increased above 32.4 degrees Celsius, this hydrated sodium sulfate, this crystalline form of sodium sulfate, changes to its anhydrous form. It means below 32.4 degrees Celsius, or you can say up to 32.4